Hello, everyone. Mr. Benson here. I'm just drinking coffee from my periodic table of the elements mug. And we're going to learn about families of elements. We're going to learn about alkali metals, alkaline earth metals, transition metals, halogens, and noble gases. Let's get right into it. Just a note that these slides come from this link, and this is a great website to go to review most everything that we need to know about the periodic table. Start with alkali metals. They're over there in family 1A, except for hydrogen, which is a nonmetal. But starting with lithium, going down through francium. We know these are in family 1A on the periodic table, and they are the most reactive metals that you'll find on the periodic table. When we look at the electron configurations, they all end in something with an S1, which means they all have one valence electron, 1A, one valence electron. And if you're following along on these slides, which I hope you are, click on this link and watch this video. You will not be disappointed. So here are the configurations of all the alkali metals, all ending in something S1. 1s1, 2s1, 3s1, and so forth. Next on the periodic table, we have alkaline earth metals. They're in family 2A, starting with beryllium, Be, magnesium, Mg. We know they're in family 2A, so they have two valence electrons. They're not quite as reactive as the alkali metals, but still very reactive. And their configuration ends in something with an S2. Looking at their configurations, so beryllium ends in 2s2, magnesium in 3s2, calcium in 2s2, and so forth. In the middle of the table, we find the transition metals. These are families 3 through 12. Remember, with the electron configurations, we call them the D block. They're not as reactive as the alkali metals or the alkaline earth metals. Think about iron, which is a transition metal. Iron does react with air or water, really the water in the air, but it happens very slowly as it's rusting. Think about gold, which doesn't really react at all. It doesn't rust or tarnish or anything. It just stays bright and shiny pretty much forever. And it's important that you realize we can't tell how many valence electrons the transition metals have just by looking at where they are on the table. Over in family 7A or 17, we have the halogens, starting with fluorine, chlorine, bromine, iodine. These are all halogens. They're in family 7A, so they have 7 valence electrons. These are where we find the most reactive nonmetals. Fluorine is the most reactive nonmetal on the table. Their configurations all end in something S2 and something P5. Here are the configurations of the halogens. So fluorine, for example, 2s2 and 2p5. So the 2s electrons and the 5p electrons are the 7 valence electrons. Chlorine, of course, is in the third row, so it ends in 3s2 and 3p5, and so forth, going on down the table. Finally, we get to the noble gases in 18 or 8A. We know they're non-reactive. Another word for non-reactive would be inert or stable. So they don't react because they're already stable the way they are. They end in S2 and P6, which means 8 valence electrons, except for helium, which we know only has 2 electrons total. So after we ignore helium, which only has 2 electrons total, neon ends in something S2 and something P6, argon, S2, P6, and so forth. So 8 valence electrons. Now, on your periodic table, you should go ahead and label these. Go ahead and write the names in. So over 1A, go ahead and write in alkali metals, alkaline earth metals for family 2A. All these in the middle are the transition metals. Here are the halogens over here in 17 and noble gases in 18. Go ahead and write that on your reference table so you'll have that handy. Here's just a summary of the reactivity. Metals get more reactive as we get to the left side of the table and further down. So francium down here on the bottom left is the most reactive metal on the table. Non-metals get more reactive towards the right and the top. So fluorine is the most reactive non-metal.